So whereabouts did we get to last week? We got to like...
I think the top of page 5.
Top of page 5. Okay, so we got to... We finished the added percentage formula, and we talked about how it used to be called the tax formula. That's important to remember because the pictures of the board work that I've got uploaded are, they're a little bit on the old side. And in some of those pictures, it's still called the tax formula, and the wording is a little different, but it still gets applied the same. I just changed the name of it so that we could apply it to other things besides money.
No, we're on page 6.
We're on page 6. Okay.
Yeah.
All right, good deal. Let me run back through this real quick, because what I'm trying to do, this week's schedule is going to be a little weird, because I've got to get everybody back on the schedule where the new stuff opens up on Mondays and Tuesdays. So what we're going to do is we're going to finish up the Percent Lab 1 stuff today, and the lab opened up yesterday. And so what we'll do on Thursday is if you want to wait to start on it until Thursday while you're in here so that you can ask questions about it, you can do that. Or if you take the route of, you go ahead and complete it before Thursday, and then you come in here and just, before you turn it in to Moodle, you just got it worked out on paper, and you want to just double check it. I'll have some copies of it printed out. Hopefully this time they'll have both sides on it. I try not to make promises I can't keep, but you never know anymore. But that way, if we just kind of have like a lab day on Thursday for my in-person classes, that way I'll get everybody back on the right schedule. The one that I've really got to try to get fixed is Hiawassee Dam. Somehow they got like way ahead, so I'm going to have to come up with a pretty radical plan for that. Apologize to Hiawassee Dam if y'all are watching this video. Y'all didn't do nothing wrong. I just got a little bit too far ahead of schedule. All right. So discount, again, we use the subtracted percentage formula. It used to be called the discount formula. It's pretty straightforward. It's just the only difference is between the old and the percent of old. It's a minus now instead of a plus, and it's still applied the same way. And then we talked about how it worked for finding the original price, and it works based off of the fact that if a discount is being applied, that means that it is being taken from the entire amount, which accounts for 100%. And that's where some folks get tripped up with discounts. We talked about how, like, if someone sees a 30% discount, they think they only have to pay for 30% of it, which is not true. 30% of it is being taken away. You pay for the rest. So that hopefully cleared that up. All right, so you said we got to this part here, the top of page 6. All right, sounds good. Okay, I'm going to pull this door too. Not going to shut it all the way just in case somebody's running behind. Okay, so there are going to be a couple of questions involving finding the percent of discount, or it might be a question that just wants you to find the percent of something completely unrelated to money. We talked about the Skittles, like the bag of Skittles. I think we talked about that in here, didn't we? Okay, just want to make sure I hadn't lost my mind. So, like, maybe if this wasn't money, maybe if this was Skittles, maybe if this was like they sell those big bags of Skittles, right? Maybe there was like 50 of them in there, and you left them out by accident, and your nieces and nephews ate 35 of them.
Why just 35?
Because that's what I've got written on this paper. Realistically, yeah, that bag would be gone. But just work with me for a minute here, all right? So let's say that you stopped them before they could eat the whole bag, but if you have OCD, you realize that they ate 35 out of the 50. So you could figure out what percent that they ate, all right? So if that was the case, you can go back to using the percent proportion, okay? So if there were 50 in their total and they ate 35 of them, 50 is the whole, 35 is the part, or you could say 50 is the base, 35 is the amount. So you throw that in the percent proportion. work the math, and it comes out that they ate 70% of the bag. All right? Which means that that is not the answer to the question, because this question will be worded as, what percent of the bag is left or something like that. So if they ate 70% of the bag, then 30% would be left. So in this case, since it's money, if something was listed at $50, it's on sale for $35, find the discount percent. So what you do is you find how much of 50 that $35 is of percent proportion. So run it through, and you find out that 35 is 70% of 50. The 70% though is not your answer. Some folks are going to want to put that as their answer because you do all that work and you get your variable assigned to something and you feel like it's an answer. But it's kind of like how in Pythagorean theorem they always say don't forget to take the square root of your answer at the end. So don't, there's always, with these there's one extra step, so don't forget it. So if $35 is 70% of 50, then you paid 70% and 30% was taken away. So what the percent proportion does for these types of money problems is they tell you the percent that was paid. And then you take that away from the 100% to find out what the discount was. You have a couple like that, but they do not pertain to money. So we'll look at that here in a minute. All right? Oh, any questions about this before I go on? All right, good.
Look it up. Fruit Loops do taste the same.
You are just not going to let this go.
No, they all taste the same.
Agree to disagree.
You're wrong. Look it up.
No, because I don't care. I'm 40 years old. I don't care that Fruit Loops all taste the same. The only thing I care about with Fruit Loops is it the one that comes with marshmallows in it. That's the only thing I care about.
Agreed.
Hey, there is no such thing.
Agreed.
All right, back to the required material. Markup. Okay, so these questions, by the way, the ones that I added in the notes, they came out of this book, and I'll show you that here in a minute because I've got them uploaded into a Lightbox gallery, and I'll show you how that works after we get done with this. So this problem said a game's production cost is $40. A 20% markup is needed for profit. What's the new price? Now it's talking about like how much it costs to put it like on a disc, not from start to finish to get it published or whatever. So the markup formula, all right, it's right here in the middle. It's a little bit weird, and I've copied this so many times it's kind of hard to read. But what it says is the retail price is equal to the cost times 1 plus the percent of markup. Now, you can also, sometimes instead of cost, it might say wholesale price. All right? And for our purposes, they'll work pretty much the same way. Somebody that's, in accounting or economics is watching this video is probably, if I get something wrong about that, they're probably going to yell at the screen. But and for our purposes, it'll work just fine. I'm just trying to think of how many other ways it could be worded. So the way it works is you take our information from up here. So it says a game's production cost is $40. All right. And then it says a 20% discount. No, sorry, 20% markup. My coffee hasn't kicked in yet this morning. 20% markup is needed for profit. What is the new price? So the new price, that is retail. All right. So retail is supposed to say equals. I don't know why they didn't copy. Retail equals cost times 1 plus percent markup. So the $40 goes in where it says cost. Your percent goes in where it says percent. And then you just start chipping away at it. You turn the percent into a decimal. Then you combine your terms inside your parentheses. And you get all the way down here to where it says R equals 40 times 1.2, or retail equals 40 times 1.2. And then when you multiply that, it comes out that the retail for this is $48. Now, like I said, I'm not, I don't have a accounting or business or economics degree or anything like that. I am but a lowly small town instructor. However, it does not seem that if it costs $40 to make a game and you're selling it for $48 and you're basically only making $8 per game, does it seem like that's a good business model? I mean, if you know more than me about it and you think it's okay, great. But to me, who has nothing to do with economics or money like that, I mean, that seems like a bad plan. Because you would at least want to try to recoup your losses, right? But I don't know. Maybe they've got it all worked out. Maybe this is typical. But yeesh. Of course, with digital copies, I guess that's how they make their money back. But anyway, so that is how you apply the markup formula if you are looking for the retail price. All right. Now, there are 3 different kinds of markup questions where they could look for 3 different things. This one, of course, is one where they're looking for the retail price. There are some when they are looking for the cost or the wholesale price, and then there is one there's one on this lab, percent lab 1, where we have to find the percent markup. Now, there was not an example of that for me to pull from to put in the notes. So when we get to looking at the student copy, that one is going to be a freebie. We're going to go through that one together, so everybody should be able to get that one. I say should, because in years past, I have walked through that problem on video, left it in Moodle, and people still missed it. Telling on themselves that they're not looking at everything. But anyway, that's neither here nor there. All right, so any questions about how to find the retail price or the markup formula? Right. This is the weirdest looking formula that we've got, for sure. We're going to come back to markup here in a minute. Couple other things. You have questions on the lab that say, set these 2 things up as a ratio of A to B. And, ratios usually get left as a fraction, right? At least they're supposed to. Well, these particular questions, I didn't catch it when I put them on the lab, but for some reason, they want you to treat these ratios like unit rates. And what do you do with a unit rate? You divide it, right? So they don't want you to leave it as a fraction. They want you to go ahead and divide it. So that's just a little boo-boo to account for, but we'll talk about that when we get to it. But the definitions of these things, a ratio is a comparison of 2 quantities of the same unit. I guess I should have put usually represented as a fraction. A rate is a special ratio with different units. We've talked about rates like in Conversions Lab 2 with miles per hour, feet per second, things of that sort, dollars per gallon, And then a unit rate is a special rate that has a denominator of 1. Most of the time, if you're dealing with rates, it's a unit rate that you're dealing with. Okay, so I've got on here that for questions 13, 14, and 15 on the percent lab 1, that you need to divide after you set the order. So we'll talk about that when we get to it. So that's the end of the notes. So let me go, where's the mouse? I'm gonna go back here. Okay. So go over to the Moodle page again and see right here where it says Lightbox Gallery. Go ahead and click on that. Now, last week on one of the videos I had mentioned that used to, when you pull up a Lightbox Gallery, there was a thing up here that lets you kind of scroll this like a PowerPoint. And then when I initially looked at it, it wasn't there. This is another great Moodle update that they keep throwing at us. They hid it unless you hover the mouse over it.
You can also use your left and right arrow.
Okay, yeah. Yeah, I hadn't tried that yet, so that's good to know too. Thanks. So go ahead and pull that up. So what this is, I just took pictures out of this. I mean, you can see where I've got it marked for discounted markup there. I mean, I've had that marked ever since I had the support classes and, you know, somebody else had this class. Because, you know, this is tough stuff. So this just kind of walks you back through percents, fractions, in decimals, all that good stuff. It's got some extra examples that we didn't put in. It has some practice problems if you need to do those. You know. So then it kind of walks into percent word problems, and it tells you, about the is over of and all that good stuff for the percent proportion, except they did not use these as a percent proportion. They used them as something called a percent equation. I try not to use the percent equation. I mean, it has its benefits and deficits compared to the percent proportion. A benefit of it is it doesn't take as many lines. The deficit is it's a little bit confusing. All right, so they just used it as a percent equation, but if you like this better, if it's not confusing to you and you would rather use that than a percent proportion, great, go right ahead. You're not going to hurt my feelings. But the percent proportion is a lot easier to deal with, even though it takes up more room. And that's the thing about the percent proportion is it's great. It's used for a lot of stuff. May not always be the best, or maybe it is. It's just one of those. It's a tool that you can use. Okay, so then this gets into the taxes and fees part of this. I got tickled reading this yesterday up at Andrews. It says taxes are fees charged by the government to pay for creating and taking care of things that we all share. I wonder who told them to say that. Probably watching this video after I post it to YouTube. Anyway, somebody at HQ is going to be like, what did he say? We have his address. But anyway, so there's the sweater problem that I used to kind of help start introducing how to set these up as a formula. Look how much room it takes up if you don't use the formulas that I've given you. Now granted, yeah, they are showing you different methods to get these things. There's more than one way to go about it. But if you use the equation, it'll line everything up for you and work out better for you in the end, especially if you have to find the original price. Because finding the original price without a formula can kind of feel like being lost in the woods. So there's the headphone problem. And then here is one that we didn't use. A bike rental company charges a 17% late fee whenever a bike is returned late. If the regular rental fee is $65, but you return the bike late, what is the late fee and what is the total that you have to pay? So this is another instance where you would use the added percentage formula. You would say that the new amount is the 65 times 0.17, or no, 65 plus 0.17 times 65. Yeah. So that's how I'd tell you to add it back. Now, if you're finding the original price, you would just work backwards from there. All right. So there you go. There's another one involving renting a snowboard, if you need to do that. Discounts and markups. All right. So there's the hat problem. Here's another one over here. This one is interesting because it has two discounts in the same problem. So let's look at this one. It says Valerie's Videos is selling all games at a 25% discount. However, you also have a membership card to the store which gives you an additional 15% off. What will you end up paying for $100 worth of the video games? Now, when you initially look at this, your instinct may think, oh, I'll just put those two percentages together, right? I wish it worked that way. Unfortunately, it doesn't. What you have to do is you take the first discount, then you take the second one off of the new price you got. So really, you're sort of applying two percentages. You're doing the subtracted percentage twice. So on the first one, you're going to apply the 25% discount on all the games. So if you got $100 worth, 25%, that gets you $75. Then the membership discount comes after the other one was applied. They don't stack. So the 25% comes off of the 100, but the 15% comes off the 75. Now the good news, you don't have any questions like that on your lab, because I figured that would be a little bit much. All right, so there's the one where games on sale again. Finding percent discount. Here's the 35 and 50 that I put in the notes. Markups. So they did markups a little bit differently. They didn't use that formula really. So that, this is just, showing you more than one way to tackle this. And then finding the original cost. Here is one that we're going to throw up on the board. I think I might actually still have it on the board. Yeah. Okay. So let me switch the camera for a minute. So, yeah. So this question said, a bakery charges $5.08 for a cake. In order to make a profit, the store marks up its goods by 70%. What is the original cost of the cake? So this is markup when you have to find original cost. All right. So we go back to our formula. Retail equals cost times 1 plus percent markup. You could also substitute a W here for wholesale if it worded it that way. So the $5.08, since it says the bakery charges that goes in place of retail right here. So we also have the markup of 70%, so that goes in there. What we don't have is how much it was before it was marked up, right? So that means C is what we're going to be looking for. So from here out, turn the 70% into a 0.7. So now you're looking at 5.08 equals C times 1 plus 0.7. Combine your terms in the parentheses. So you've got 5.08 equals C times 1.7. Then finish it off with inverse operations. If you have C times 1.7, divide by 1.7. So now you know that it cost $2.99 before the 70% markup. So if the person running this bakery did not make it $5.08, they wouldn't make any money off of it. They would just be making back the amount they spent, or the price of the materials that they used. Which, you've got to, you're doing all this to make money, so you have to mark it up. Sounds like it's a bad thing, but what's bad is when, inflation starts kicking in and it gets, really, really bad. Now this class used to have a lot of questions dealing with inflation between now and then and things like that. But I took that out because it was sort of causing more headaches than it was providing a learning experience. So I just took it out. But yeah, so that's markup if you have to find the original cost. So this time the retail was given, we had to find the cost. Now, like I said, there is one on the lab where the markup percentage is missing, so I'll show you how to do that one when we get to it. All right? Okay. And then here are a couple of more practice questions. I just threw them in there. I know not everybody looks at them. Some people do, some people don't. But again, ones like number 4, where you've got 2 percentages, you don't have any of those. So you don't have to worry about those. All right? All right, let's go back to the main Moodle page. All right, below the Lightbox gallery is our percent lab 1. So I initially had this set to where it opened up in a new tab, but Moodle updates. All right. So if you would, I don't have any paper copies of this yet. I'll have some for you on Thursday. But if you would, just go ahead and pull that up on Moodle. If you've already printed it out, that's great. You can just look at that. But if you've not printed it out, pull it up on your screen, and we're going to go through it together. Yes?
I meant to say, I didn't
last week because I thought it would open up on the 5th for some reason.
Oh.
But I inputted the answers. I started yesterday and finished putting them in today. It did not take 18 hours, but Moodle is saying it took 18 hours to finish it. It only took like about an hour.
Huh, okay. Well, I would hope it wouldn't take 18 hours. I mean, 1 or 2 at most, but good to know, good to know. Okay. Yeah, when you're working on these in Moodle, try to be careful about, like, if you start it, open it, and then, you know, something else comes up and you got to go work on that, and then you come back to it, because sometimes it might log you out. And I don't know for sure if it will let you get back into it. The way it's been acting lately, sometimes it will, sometimes it won't. So just be careful with that. Okay, 1 through 5 are percent proportion problems. You know, easy peasy. Just make sure that you set them up correctly. Read the sentences, look for the clue words, is or of, and that will help you get it lined up. All right? So any questions about those? All right, good. So that's 1 through 5. So let's skip to number 6. Okay, number 6, Terry and Ricky went on a 40-mile canoe trip with their class. On the first day, they traveled 16 miles. What percent of the total distance was that? These are like the one we saw with the original price and sale price. You know, it was originally 50, it's on sale for 35. Same idea. It's just on this one, the question is not asking how much of the trip is left. It's asking how much of the trip did they travel. Make sure that you know which one of those is the whole distance of the trip and which one is the part of that distance that they traveled. I have had people in semesters past set this up upside down. So just be very careful with that. 7, a hardware store had monthly sales of $72,400 and spent 8% of it on legal fees. How much was spent on legal fees? Pretty straightforward percent problem. All right, just to kind of get you back into that. 8, the regular selling price of an item is $55. For a special year-end sale, the price is at a markdown of 20%. Find the discount sale price. So on 8, that is where you're going to go back to your subtracted percentage formula, and you don't have to find original price, all right? You're going to find the new price for number 8. All right, number 9 is the one that you're going to get for free, and I'll show you where that one's at. So number 9, a store manager paid $124 for an item and set the selling price at $176.08. What was the percent markup? So they paid $124 and they set the selling price at $176.08. So let me switch this. Wait, that ain't gonna help. Let's do that. Yep. Okay. So I'm gonna scroll past this one. I'll come back to it in a minute. So here is number 9. Okay. I just threw that one in as a freebie to make up for not including it in the notes. So the way you set it up is you go back to the markup formula. Retail equals cost times 1+% markup. All right. Then the retail price is, how much it was after the markup was applied. So that's $176.08. The cost is how much it was before the markup was applied, which is $124. So you set it up as $176.08 is equal to 124 times 1 plus the percent of markup. From there on out, from this part here, oh no. Whew. This thing, sometimes I just want to throw it. From this point on, it become, well, no, hold on. Oh, nothing is working this morning. From that point on, it's inverse operations the rest of the way down, okay? So the first thing you're going to do is you're going to divide off the 124 on both sides. That's going to give you 1.42 on the left equals 1 plus a percent markup on the right. Now, this is what you're trying to isolate to solve it. It has a 1 being added to it, so you have to subtract the 1 off on both sides. Okay? So when you do that, you get to here, which is 0.42 equals percent markup. Now, from here on out, and again, these types of questions were some that I inherited. There's not really like a clear way to show you how to throw the percent on one side as opposed to the other. So I just said, just think of it like you're going to multiply both sides by 100, because you have to multiply the left side by 100 anyway to make it a percent. So just do the same with the right and just take the percent sign off. That's the only one like this that you have on percent lab 1. You've got a couple more of these on percent lab 2. All right, this is not the last time we're going to see this. This is just, I figured I'd just throw 1 in now to kind of get you used to it. I just forgot to put it in the notes. So just make sure that at some point you get that one straightened out for number 9. Because like I said, I've had people not look at this and not get number 9 correct. Stranger things have happened. Okay, so that's number 9. It's in Moodle. All right, number 10. The appliance store where the Scott family shops offers a 9% discount for paying cash. The Scott family's total after they received the discount was $50. What was their total bill before the discount? So this one is subtracted percentage to find original price. Okay? The subtracted percentage formula to find original price. 11 changes gears a little bit. 11 says the population of the U.S. in 2000 was roughly 280 million. Express this as the number of people per square mile. The land area of the U.S. is roughly 3,536,000 square miles. What do you think one reason is that I've had a lot of people miss this one in the past? Yep, putting the wrong number on the top. Now that leads me into why they do that. It's because the people that wrote these questions did a very, very sinister thing of writing million as a word and not a number. So they look at it and they think, oh, well, 3,536,000 is much bigger than 280. Yes, it is. However, it is not 280. It's 280 million, which is much bigger than 3,536,000. So that is one reason why they miss it. Very good. The other reason why they miss it, which leads them into why they set it up upside down, is because this tells you how to set it up. People per square mile. People on the top, square miles on the bottom. So, read these questions very carefully, and that's not foolproof. Sometimes you'll read it 2 or 3 times and still not see that until somebody points it out. So that's why I'm pointing it out now. Yes?
So, I'm not asking this question as like a joke. I genuinely just don't understand. But like when you're doing percentages of like people,
Yeah.
what does it like correlate to when there's a decimal? Like, because one of the answers on here is 0.8 people.
It correlates to the fact that it's really hard to quantify everything. They used to say the average American household was, 2 parents and 1.75 children. And I'll be like, I don't want to see the 0.75 because I don't know where the other 25% is going to be missing. I'm not making that up. I mean, it's like, it really got weird when they said it was like 2.3. Like, ooh.
Like, what happened to the other 0.7 of the total?
Yeah, it just it speaks to the fact that you can't quantify everything. You can just say it's like roughly, In most instances, you would just round that to the nearest whole number one way or the other. But yeah, I see your point.
Maybe you account for amputees.
Maybe. Could be. Never know. Number 12. The national debt was about $6.9 trillion at the end of 2003. Express this quantity as the number of dollars per person. So again, assume a U.S. population of 280 million. Same kind of thing you're going to watch out for. Okay, it tells you how to set it up. Okay, so you're looking at dollars per person. So just make sure that you set it up that way. And that is not $6.9. That is $6.9 trillion. So just be aware of that as well when you're typing it in to your calculator. All right, 13, 14, and 15 are the ones that I mentioned on the notes where we said to divide after you set the order. Okay, divide after you set the order. So it tells you up at the top, okay, set it up as a ratio of A to B. Round as indicated. So it's going to tell you where to round it to. All three of these say to round it to the nearest hundredth. Okay. Now, ratios by definition, they are supposed to be left as a fraction, right? Are any of these fractions? No. These are all more like unit rates. Okay. So when you're working these out, just think. So treat like unit rate. Really, the only thing that makes them ratios is that they all have the same unit. All right, but they still divided them like a unit rate. So they couldn't make their mind up what they wanted to do with them. Plus, I mean, would you want to do 3.1 million over 1.2 million as a fraction and reduce it? No. Okay, so yeah, 13, 14, and 15, just treat them like unit rates. Okay? 16 and 17 are the bane of my existence on this lab, and they have been ever since I made this lab. And I'll tell you why. These two problems right here are the main reason why I changed the name of the two main formulas to added percentage formula and subtracted percentage formula. Because when I still called them the tax formula and the discount formula, nothing about that name told the students that they could use those on these types of problems. And why should it, right? Because it sounds like money formulas. So that's why I changed it. All right? That is not the reason why it is the bane of my existence. The reason why they are the bane of my existence is because on this picture, where I've got the formulas, I got the percent proportion, I got the markup formula, and I've also got how to set 16 and 17 up right there. And I have had students argue with me when they'll send me a Moodle message. The conversation will go like this. I don't know how to do 16 and 17. It's in Moodle on the picture. I can't find the picture. Scroll down further. I found the picture, I still don't see him. So then what happens is most of the time I'll usually email them a picture like this. I mean, I can't cuss them out.
And then they'll go, oh.
Yeah, they're like, oh, that's where it was.
Oh my God, that's something I would do though.
Well,
Yeah.
it's also something that my daughter would do because, it's like, honey, get your shoes and pick them up. I don't see them. They're on the floor beside the chair you're sitting in. So, but yeah, anyway, now granted these are using the old tax formula, so let's just make a real quick adjustment because I've not had time to, fix this yet. So on 17, it says tax formula. That's the added percentage formula, okay? So instead of total equals cost plus plus tax times cost, we're going to say new equals old plus percent of old for that one, okay? And then now discount formula is called subtracted percentage formula. And the formula for that is still the same, okay? So, yeah. It's like when I talk with the other instructors, you know, because they say that they'll have people tell them that they like that I record new videos every semester that are current. My reply is always the same. I can record videos all day long. I cannot make people watch them.
Do you keep funny stuff in?
Well, I don't have a TA to do any editing for me, so yeah, I just kind of have to. I just upload it as it is. Yeah. So like I said, yeah, it's a miracle that the FBI hasn't knocked on my office door yet. But anyway, so there are 16 to 17. Now, they are not freebies. They're just how to set them up, okay? Because like I said, in semesters past, it was not very clear that you could use those two formulas for something besides money, and rightfully so, because nothing about their name made that clear. So for 16, all right, you're going to use the subtracted percentage formula, and for 17, you're going to use the added percentage formula. So this is on the video. You can go back and get it written down in your notes if you need to, but for now, since we only got 4 minutes left, I'm going to go back to the student copy for a minute. All right, so again, 16, in a local election, 31,900 people voted. This was a decrease of 7% over the last election. How many people voted? Decrease, subtracted percentage. 17, in a local election, 25,100 people voted. This was an increase of 6% over the last election. How many people voted in the last election? Added percentage on that one. And on 16 and 17 both, you're finding the old amount. Okay? You're finding the old amount on both of them. 18, the regular selling price of an item is $54. For a special year-end sale, the price is at a markdown of 20%. Find the discount sale price. So this is just the subtracted percentage formula to find the new price. 19, same thing. Subtracted percentage formula for the new price. 20, Alex and Juana went on a 75-mile canoe trip with their class. On the first day, they traveled 21 miles. What percent of the total distance was that? So this is like number 6. This is like number 6. Okay? Just make sure that on number 20, you put the total distance in the right spot and the part of the total distance in the right spot. All right? Don't forget, and I'm going to send an announcement out about this later this morning. Don't forget that you do actually have something due today. All right? The conversions test. Now, I sent an announcement out yesterday about this right here. Okay? So, back in the good days of Moodle, when I assigned test groups to individuals, when you looked at it on the student end, it only said 0 of 1. It said you had one thing to do, and life was good. And then the powers that be at Moodle said, we're going to send out some updates to make it pretty, and we don't care what it breaks. Well, this is how it's always looked on my end. Now that's what it looks like on your end. So you have one test showing, but it says progress 004. The quick answer is there is no fix for that. We're still trying to get Moodle to fix this.
That's funny.
Where I can't scroll it. Yeah. So my answer to you is no, you do not have 4 tests to do for the conversion test. You've only got 1. That 4 is because I've got 4 different versions. Now, before y'all leave, I got to get attendance. Okay, I forgot to do